A warm welcome to everyone, and we'll start our session just in a moment. But just thought to introduce about me, and if you can give some background about you, if possible, quickly. Can you tell me from which part of the country you are, and what are your expectations here? Quickly, a minute, round of minute, it would definitely help us. Yeah, anyone would like to share from the which part of the geography you are? Something what you are expecting here? Great. So Sapna is from India and wants to know what Amazon has to offer. Alexis from USA. Shashidan is from Solution Architect from Virginia. Cool. Kaitjuar from India. Great. Amrin from California. So again, I'm seeing a lot of people from USA. Maybe the time is the critical factor because in India it might be a little early morning. Sri Krishna is from Hyderabad. Good. Again, warm welcome to everyone. And let's understand. So this is Edureka. I'm sure you all know what Edureka. We are doing a huge number of courses, and we also have one of the offering called Amazon Web Services. And you can get more details about the curriculum at the link given here. I'm Tarun Dave. This is my email ID. And frankly, my passion is Amazon. I want to keep learning Amazon more and more. And every day I would think what I can do something more in Amazon. That is my passion. Uh, just by degree, you can say I'm a Amazon Certified Solution Architect. You can always connect me on my LinkedIn ID. So these are the few numbers which talks about me. I'm having around 14 years of IT experience with, I would say now it's more than 4 years, almost 5 years of the Amazon experience itself. I have conducted more than 20 plus Amazon workshop, classroom trainings, and taught almost 700 plus IT associates, developers, architects, students on Amazon, cloud computing. Now, in today's session, we are going to cover the two aspects. First is we would cover the cloud computing because I believe we can't start without the cloud computing. So we would give you some overview about the cloud, and then we would take you to the Amazon, a brief introduction about Amazon, and we would discuss a scalable Amazon architecture case study. So that is the agenda we want to cover in this an hour, whatever we have planned for you. And as I mentioned, never stop yourself from asking any question anytime. You do not need to raise any hand. You can just drop a question, and I would, in between in the logical break, I would keep answering those questions as much as possible. If possible, if I could not answer certain, even after the session, I will take up that also. With this, let's start our day. I would like to know how many of you have used cloud computing, and if yes, which cloud computing? Great. So quite a few have not used. Kiran says uh, it's explored the Amazon. Madhvi has explored the Amazon. Amreen and Ashwin also has explored the Google App Engine. One very good answer from Amreen as well as Kiran. Some of them say very new to that and not used it. And I would say you have used it. You are using day-to-day cloud computing. Let's see how. But before we go ahead, see, I like to make the stories. I like to make the go in a real life examples, and that's what I would like to create a little hype first. This is by the Mark Weiner, founder and chairman and CEO of the Salesforce.com. And it's a very good point he has brought out. The cloud services companies of all sizes is for everyone, and cloud is a democracy now. You go to the market, you ask, and now there would be a case, you pick up a stone and throw in the air, it's a very likely it will fall on a person who might say, oh, I am using the cloud. So that's what the cloud is becoming commoditizing. Everybody is cloud, and that's why what Mark Andreessen says, every kid coming out of Harvard, every kid coming out of the school now thinks he can be the next Mark Zuckerberg. In India, if you go, people would think I am going to be next Flipkart, isn't that? Because with this new technologies like cloud computing, that is actually becoming little more possible. Reason, you don't have to invest huge in the infrastructure. Quite a few of your infrastructure cost is already optimized, saved, and you would be going more in a different, more lot on a cost saving aspect. So cloud is there. Cloud is there for helping you, for improving your efficiency, for benefiting you on the cost aspect also. And that's why this is the cloud service market growth. And I'm sure most of you started using cloud somewhere here or here or here. I don't think anybody would go and say I started cloud in 2015. I'm sure everybody of what you are doing is here, somewhere here only, a little much before that. And this is what they anticipate by 2018. This is how the cloud market is growing up. So cloud is growing. Cloud is a sustainable model. Cloud is in demand model. And that's what the growth they say is that the predicting and cloud computing continues to grow at a rates much higher than IT spending generally, growth, cloud service, all that. And they believe that's by even 2015 it would be more than 180 billion. So that's a huge, huge number. Now all this hype, all this, what is cloud? And the problem in these days are everybody comes and says this is I am on using a cloud. I just mentioned if I pick up a stone and throw on someone, it's likely he's using cloud, or he might come out and say, hey, I'm making my cloud. And that's why Larry Ellison has to come out and say they don't call it an internet anymore. They call it a cloud. And I see that so many people when they say I want to save the data, they would come and say, let's save on the cloud. My dear friend, internet is not the cloud. It's a different. And we need to understand, though you are using it day to day, why is it a cloud? That's what we are going to discuss now. And the same thing, what I'm talking about. When you go and meet the people, you ask anyone who was just say, I know the cloud or I'm using the cloud. They would say, oh yeah, something I put in the internet, that's a cloud. Or somebody say, I'm using the iCloud from the Apple, that's a cloud. Why? Nobody knows. This is like a few blind men and a huge elephant. Somebody touching its ear would say it's like a fan. Somebody touching its legs would say it's like a tree. Everybody would have their own perspective. So that's why, what is cloud computing? Let's try to define it. As per the Forrester, cloud computing is a form of standardized IT-based capability such as internet-based services, software or IT infrastructure offered by a service provider that is accessible via internet protocols from any computer, is always available, scales automatically to adjust to demand, is either pay as you go, advertising based, has web or programmatic based access control interface, and enables full customer self-service. Right? Everybody clear with the definition? Frankly speaking, even I am not so clear with this definition. Don't you think this is little complex? Don't you think what is all this you are talking about, the internet protocols from anywhere or scales automatically? What are you exactly talking about, Tarun? Just don't take us on a drive. Explain in a little layman language, can you? Let's try some other language definition. As per NIST, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. Now, NIST is a National Institute of Standard and Technologies, which is the authority of defining any definitions. So this is what we are going to follow. And they say that can be rapidly provisioned and released with minimal management effort or service provider interaction. Does it make more sense now? Agreed. So Arun has a very good point. It's a more complex. I completely agree with you. This is more complex. And that's why let me redefine this. Any business service. I'm using the word very carefully. Any business service. Now, what do I mean by a business service? Whatever you are offering your business as a, if you are offering a business as a service model, like you are offering email as a service, you are offering collaboration as a service, you are offering hosting as a service, you are offering virtual machines as a service, any business service, something business service you are offering, which is accessible over internet. Let me go back to my previous slide. Any business service which is accessible over internet, so accessible over internet or internet protocols, which is charges you on a pay as you go model. So pay as you go, whatever you are consuming, it would charge you on that, which is available on demand. So whenever you require, it's available, which is elastic in nature. So it can scale up, scale down, and uses the resources optimally. Any business service, I'm just making a very generic statement, any business service. Now you think about, what are you offering? Are you using the documents as a business service? Are you getting a email as a business service? Are you getting a collaboration as a business service? Are you getting something else, the social community as a business service, which is accessible over internet or internet protocols, charges you on a pay as you go model, available on demand, which is elastic by nature, and uses the resources optimally, is known as a cloud computing. Sorry, so Ravi says combined definition, please. I didn't get your point. So can you please elaborate what you're looking? I'm just saying a very simple language. Now you can start thinking in your own world also, that what am I getting as a service? You think about the documents, you think about the storage, you think about the virtual machines, you think about the email. Are they offering me as a business service? Yes, they are. And how they are going to, if, can I say everything is a like, is this accessible over internet? Is it charging me on a pay as you go model? Is it available? Is it elastic? Is it resources, using resources optimally? That is called the cloud computing. Does it help you understand little better now? Ravi is a good point. If there are more than one services, then yeah, so if each service is being offered you in this way, it would help you. Or you can combine both service and offering this as a package, but if both the services total package is meeting this criteria, it would be there. Now I'm sure, see, this is not a definition written anywhere, right? You would say, then Baba Tarun, where are you bringing this? Where are you bringing all these new jargons of the resource pooling and the on the internet and on demand? Where are these coming from? Right? Then let's try to go little one step deeper and try to understand those five models again. What are those five attributes I spoke about? Broad network access, something available over internet to everyone. You are today accessing from Chennai or Hyderabad or Germany or California or Los Angeles inside or USA or in the New York or Dubai. Whenever you are accessing from, it is accessible. It's a broad network access. It's a elastic. Now, what do I mean by the elastic? When you need, let's try to understand our best case of the Flipkart. Flipkart had a big bang sale something around 3-4 months back, and the biggest problem was the site went down. Right, we all know that. That's such a history, people know that. By the way, I just request again everyone to not raise your hands. You can just put this in the your question box. I would answer them over the period when they're during the logical break. So Flipkart failed. The reason, they could not anticipate that this would be a so huge rush of the users. Now, how do you meet the that part? In case, I don't know where Flipkart is, but in case if they were on a cloud gives you a rapid elasticity. So you want to scale beyond that. Today you need 100 machines, tomorrow you need 300 machines. It would be able to do that just in 5 minutes or 10 minutes. That is what your rapid elasticity is. You would be able to scale up or scale down. That's what your rapid elasticity is. Today you need to use for 100 users, tomorrow you need to use for 1000 users. But how would it provide? It should have on-demand self-service. It should offer you the on-demand self-service, which should help you that, okay, whenever I need, the resources are available. Now, if you have a server at your house, right, and or just take an example, you want to procure a server. Generally, how much time does you take to procure you? 1 day, 2 day, 30 days? If you're an organization, you have to study the different codes, you have to understand the conditions, means the what are the size and everything you want to do, and then you raise the PO, and then you get the place the order and you get it. 1 days, 2 days, 10 days, something, right? Now imagine if you have a need that I want to scale up in just, I am expecting a huge load in just 1 hour. What would you do? Can you go to the shop, get that immediately, fix it at your house or whatever the data center you have, and make it running in 1 hour? Highly unlikely. What if I tell you you can get the same thing in just 10 minutes or 5 minutes? Wouldn't you love that? Wouldn't you say, oh, that's an interesting case? It is, because cloud offers you on demand self service. You can scale up in 5 minutes. That is the power of power, and that's why it offers you the rapid elasticity, because it offers you on demand availability, cloud. And now you would say, but then what is the limit? Today there are 1,000 users, there are 10,000 users using same cloud. Wouldn't it die out? Would it be able to scale up? You say it's a rapid elasticity. If you go to the public cloud providers like Amazon, Google, Microsoft, they have virtually unlimited infrastructure. Now why I call it virtually? Because physically they might have a finite, but you keep on demanding, they would keep offering you something all the time. And why am I saying this? Google, or sorry, Amazon is massively scalable infrastructure. And why I say that, I again come to that point in a while. But here we are just trying to understand the cloud, that it offers you with the on-demand self-service, gives you the rapid elasticity. And this is not helpful for me. If I demand a resource now, I get it. Now, how are they going to charge me? If I tell you, you need this resource for 10 hours, I would charge you for 10 hours only. You need for 2 hours, I would charge you for 2 hours only. Imagine SAP HANA, which cost you almost some hundreds of $1,000s. If someone comes and tells you, do you want to practice SAP HANA? I would give you for 10 hours and you have to just pay me $20. What would be your reaction? A licensed software which you can use for your practice just for $20. Isn't that great? Amazing? That's your measured service, because cloud offers you pay as you go model. Whatever time you are using, you start it, you launch it, you use it, Amazon charges you or any other cloud charges you. You terminate that, Amazon would stop charging you. And for that they offer a measured service. They measure internally and charges you based on that. This is your cloud. Four attributes: broad network access, rapid elasticity, measured service, and the on-demand self-service. Now let's try to understand something more here in the resource pooling. Do you know what is a multi-tenant system? Does anyone know? Great. So someone says, I was about to ask. Now, I won't say it's a more than one application. Let's go by an example. Suppose you have built a government software. Now you have to deploy that for various states. So let's take the buzzword smart city. You have created a smart city software. Narendra Modi loves this. And he wants that, okay, I am procuring this software, go and install first at the Gujarat. Okay, so what you have to do is you have to go and install at the Gujarat. But Gujarat Chief Minister says, no, no, don't do it. Sorry, who's Gujarat Chief Minister? Yeah, Anandiben. She would say that, don't do it now. I need some configurations. It should support the Gujarati language. it should have the certain of the text logs because we are charging our state based on this. It should follow this processes. Then only it should be able to implement. You would say, okay, I would manage that. Then you say, I have to now implement at the Maharashtra level. So Fernandes government says, hold on, are you supporting Marathi language? Are you supporting Hindi language? And are you following this all? Because it's a Mumbai. Mumbai is a business hub. We have to follow certain standards. You have to offer me this way customize. You would say, okay, I'll do customization for you also. Now you go to Delhi. The dear friend Kejriwal has some different thoughts. Are you offering something for the Aam Aadmi? What if my rickshawalas also want to use this? Right? He would have. Can you make it more simple? It can be accessible over the mobile. They won't have the internet or their home. Is the right point. How would you work this? Now, are you going to make three softwares for them? That's a challenge. Rather, if you make a single software for them, which might be hosted on a single data center and serving all three states in such a way that when someone comes to the delhi.gov.in, he would see something in a Hindi, he would also see something with a better mobile UI, or he would be able to see that. When he comes to the maharashtra.gov.in, he would be able to see something in a Marathi, as well as he would be having the Maharashtra process. Or somebody is coming to the gujarat.gov.in, he would have something in Gujarati available there. The same software is customizable for multiple people. They can access it without knowing how the backend level it's being managed. What is this? This is a example of a multi-tenant system. A multi-tenant is a software is configured for the multiple tenants who would be using it as per their requirement. Now the tenant here is what? Is the tenant same as an end user? No. Tenant is a group of the people. Tenant is like for the multiple people coming together and they are accessing the same application. That makes it's a group of collection of people makes a tenant. And for that tenant, your application is customized, right? So this is your multi-tenant system. And why this multi-tenant you brought into the place of the resource pooling? Because you achieve multi-tenant if you're doing the optimal resource pooling. You would be able to achieve that. Now, how or what is optimal resource pooling? In that case, if you think about, you have a 20 GB RAM machine, you want to distribute, or 200 GB RAM machine, that's a memory, and you want to distribute among these 3 or 4 states. You have hosted one machine, one big machine where you have the serving 4 states. How would you manage that? Configure same machine in a virtually such that each state application would get 50 GB RAM. Optimally using your resources with the resource pooling power, right? So let's come back to our original thought. Cloud computing, a business service which is offered over intranet protocols, which is available everywhere, broad network access, which offers you rapid elasticity, so it can scale up, scale down, which is having a measured service as a pay as you go model, and offers you on demand also whenever you need it's available, and available or optimally uses the resources, is known as a cloud computing. Are we all clear with this now? It's a very important. This is the very fundamental or foundation stone for you. So there's some question. I'll come to that in a while. Are we all clear or any doubts? Now, where did I bring these 5 attributes from? I did not reinvent the wheel. I did not create something my own. If you go back to the NIST definition, which is the standard definition, it says the cloud computing model is composed of 5 essential characteristics, and I'm using that only to explain you. So now let's go back to, if I want to make your life the easiest one, anybody ask you, do you know what is cloud computing? You can say any business service which is following 5 attributes defined by NIST is a cloud computing. Does it make your life so easy to remember? Now they can grill you. What do you mean by the business service? Then you can say something offered as a service models. What are the service models offered by the cloud computing? First one is a software as a service. Any software which is offered to you as a service. Now you would say software offered to me as a service. Okay. All those people who said, I am not used the cloud before, I am not aware about the cloud before. I just want to ask you, have you used Gmail before? Have you used Google Docs before? Google Drive before? Dropbox before? Facebook before? GoToMeeting? You are using right now WebEx. You are using cloud in one or another way all the time. These all are the classic examples of the cloud computing. They are offering something for you in the cloud way. How? You said Gmail is it Gmail giving you all this? Let's try to understand the Gmail. Gmail offers you email as a service model. So where a software is offered to you, you have to use it. You don't have to worry about how it's working. Now, in that software, it's available everywhere. Broad network access. You can access from your mobile devices, tablets, your laptops, your machines, desktops. Now, Gmail is not only for the people like you who are the last people who are using it, the like us who are using as an end user free of the service. Gmail has a service where it offers you for the various small and medium business also. My email ID tarun@edureka.co is actually a Gmail ID because Gmail gives for those business service providers. You don't need to make your own email service. Rather, you purchase your own domain, map that here, and create your users. It provides you on-demand service that you create users as many users you create. I would charge you per user basis. So per user, I charge you $5 or 150 rupees or 200 rupees, whatever is the charge. Easy to manage. So they are going on a pay-as-you-go model, charge you on a per user basis. On demand, if you need a new user, you can create it. Rapid elasticity, we know you can keep on sending mails unlimited over there. Gmail would never die down there. It would never say you are over quota. And it is doing this resource pooling with the multi-tenancy optimally. It is offering for Edureka. I myself is having almost 6 IDs from my various clients where they all have configured in the Gmail. But the domain name is something. So if you say Tarun at that edureka.co or Tarun at that abc.co or Tarun at that xyz.co, I have those. At the back end, it's they are using Gmail only. This is how Google makes a cloud offering for you as a software as a service model. Are we all clear or extremely clear, perfectly clear now with the models and all that? The models I'm going to explain more, but what is cloud computing and why is it there? Everybody clear? Exactly. So I already got 3 answers. Say we are already using the Gmail as a mail service. Great. So good to know. Thanks, Sapna. Thanks, Shashidhar. Thanks, Ambarin. Madhvi. Good. So we all are doing great. Now, coming back to this is a software as a service, where a ready software. Now, think about you are a developer. After deploying, what would you need? You need a you need to host somewhere. And I said, if you go and procure the infrastructure, it would take a days, months, sometimes for you. How about a virtual machine available to you when you request in 2 minutes, in just 2 to 5 minutes maximum, you would get 244 GB RAM machine with 16 terabytes of hard disk with Amazon Linux installed on that or any Linux. What would be your reaction? And the best part would be they say, did you use only for 2 hours? I would charge you just $2.50. I would not charge you more. And your eyes would be blown up. Wow, 244 GB RAM, 16 terabyte hard disk, and I use 2 hours. I'm paying only $3 something amount. That's where the infrastructure as a service model comes in a picture, which offers you virtual machines, virtual servers, virtual compute power, virtual network, all that. Amazon is the best or the leading or the market leader example of that. And from infrastructure, we go to the platform as a service model where you think, okay, I am a developer. I don't care what kind of a machine I get. I don't want to manage infrastructure because if I have the infrastructure, I have to manage for the scaling, I have to set up something. I don't want to do that. I'm not an IS guy. There is a platform as a service model like Google App Engine, Amazon Elastic Beanstalk, Microsoft Azure, which would help you that you just develop your application, give it to us. We would manage infrastructure for you. We will manage the scalability for you. This would be taking care of you, right? So this is a platform as a service model. A platform is offered to you which would be taking, you just have to focus on the development part or the infrastructure related backend thing like scaling up, setting up scaling, scaling up the load balancer, scaling up the setting up the backup. Everything is taken care by this platform. So it's a platform as a service model. Now one question there says, can you explain pay as you go model a little bit again? This is what I explained. You used a virtual machine for 2 hours and you pay only for those 2 hours. You don't pay for anything. So they charge you hourly basis like a dollar 50 something or 5 cents, 10 cents, something like that. If you go to the Gmail based on a software model, it might charge you per user basis. They would say per user I would charge you $5. So you create 10 users, you would pay me $50. That's the case of the thing. Right? So these are the service models and the attributes of the cloud computing. We are spending a little more time than the anticipated because I believe you have a few questions also. And but I want to be absolutely clear about this concept. We will be now rushing to our I won't say rush, we will be going to our Amazon part very soon. Now on the deployment side, you would have I just got a request. We would like to finish something by 8:30. So what I'll do is I'll park, if possible, I like to park your questions just for a while. So people who wants to go to their office in the India early morning, they could at least rush off. And for all other questions, I would take after 8:30. Do stay with me. I would not run away, but we would answer all those things. Okay, coming back to the deployment models. There are the three major deployment models or four major deployment models identified by the NIST. First one is if it's available over internet, anybody can access it. That is a public cloud. If so, Amazon, Google, Microsoft are the perfect example. If you don't want to make it public, you want to make it your own cloud. That is also possible. There are softwares available. You need to have the hardware available, and you can do that. That is called a private cloud. Sometimes you want the mix of both. Some of the things you want to store in a private, some of the things you want to store in a public. That is called the hybrid cloud. And sometimes a cloud which is not public, which is not private, that is community cloud. Now I'm confusing, right? Let's take the case of the our city application, uh, smart city. Now what happens here, like Maharashtra and Gujarat says, let's tie up and make. We don't want to make it that this guy. We don't want to host same thing for everyone on the same data center. So they would make their own data center where the application is hosted only for Maharashtra and Gujarat citizens. So it's a multi-tenant citizen application. It is not private because it's not for a single tenant. It is not public because it is not available to everyone. It is not hybrid because it's not mix of both. It is a community deployment where people with like-minded or the with the same purpose come together and form their own cloud which is accessible to that special purpose group only. That is called the cloud computing. Now let's try to understand, this is the cloud models. Now you want to also understand cloud with the on-premise and the hosted model also. In the cloud model, it would be pay as you go. So if you have stopped it, you have this terminated, it would not charge you. But at the same time, you lose certain control. And when if you join our session, I would be explained in little more depth about that. What do I mean by the less control and the less responsibility part also. But you start losing certain control over there. At the same time, if you go for your own managed infrastructure, it's your own, you have the full control, you are the responsible for all backup and availability and everything. While it would be kind of a static environment because it would not be able to scale beyond certain things. If you go for a hosted, it would have a mix of both, but hosted still would have a control flexibility. It would not be able to scale beyond certain limit. Cloud has the best part is it's a pay as you go model, so very cost effective and virtually unlimited resources. These are a few classic examples of the cloud in AWS PaaS and SaaS models. You can see more and more over there. Now we know about what is cloud computing. Are we all clear with the cloud computing now at least? Are we good? Now when you go out and ask someone or someone says, what is cloud computing? You know this, right? So just Kajidhar says, I'm muted. I have muted everyone. I always keep on mute because then there is a lot of noise starts coming for that. If you have any questions, you can keep posting here and I would definitely answer in a while. Okay, so let's move to the one more important aspect. What is Amazon Web Services? We know Amazon.com, Amazon.in, or dikhao. That's the mantra going on in India right now. It is a seller business. Apart from this, now you can also sell your products on the Amazon, right? It's a possible. After this, you also have Amazon has a IT infrastructure business, which is the highest uh, booming or the highest growing business of Amazon. Then the growth wise, it has shown almost 140% plus the growth in last 1 year, and that's the power. Amazon.com.in is still the largest online retail service provider. You can sell your products, but the things which is getting attention of everyone is Amazon Web Services, and we'll talk a little bit about that today. Amazon Web Service has a huge portfolio, almost 40 plus services, and you name it's a very likely the service would be there. You want a virtual machine, it is there. You want a virtual server, it is there. You want a virtual desktop, virtual memory, virtual networking power, it is there. Now you want the load balancing service, you want the automation monitoring services, you want the database services, it is having a Oracle, MySQL, Postgre, MS SQL, all as a managed services. You want the security part, it is there. You want the NoSQL database, it is there. You want the data warehousing services, it is there. You want the storage services, it is there. You want the Hadoop or the machine learning, it is having there. You want the mobile analytics, it is there. You want the mobile based services, it is there. You want email, you want search, you want queue service, you want the transcoding, you want the workflow service, it is having everything. Content distribution network, almost 40 plus services. You name it, it is having it. That's the Amazon Web Services. Huge portfolio. And again, I tell you frankly, no one would be able to teach you that whole huge portfolio in just 8 weeks or 10 weeks or so those sessions. And even people would not be able to digest that also. So it's a very important you identify the foundation subjects which is helpful for you, which is helpful if you want to prepare for Amazon certifications. You can prepare on that and then you capitalize on that. Somebody should lay down your foundation very strong. Now you know how this services works. You can learn other Amazon services very easily on your own, on demand, self-service way, right? And that's what our curriculum would help you, which I'll talk in the later part. But for now, what we are focusing more is why Amazon. So in 2004, Amazon.com said it's almost $7 billion plus retail business with more than 8,000 plus employees and whole lot of services. So imagine a $7 billion business. To sustain that, you need to have a X number of infrastructure, right? It must be, you would say, hundreds, 200, 300 kind of a infrastructure you need to manage that business. Amazon Web Services every day, today, every day, we are adding similar kind of a server capacity that can power a 7 billion enterprise. Now, don't you think that's the power of this growth? Virtually unlimited infrastructure or massively infrastructure. That is the power of the cloud computing or Amazon, and that's why it is so popular, so leading in the market. Now, let's come to a use case, and that's the flavor of the season. Cricket, like IPL, everybody following, or quite a few might be following. Now, we talk about a little long back. This is on the February 24, 2010. Sachin Tendulkar became the first person to hit a ODI double hundred. And that's a record in itself. It was that time. Nobody has imagined that in just 2 years or 5 years, there are 5 to 6 people who would pass his record and all that would be possible. But it did happen. But when that record was broken, Sachin broke many things, right? The international records and all that he broke. He broke a unique thing which he never intended to do. He broke the website of Crick Info. Now you all know, if you are following cricket by any chance, you would know what is Crick Info. That is the one of the best website to ESPN Crick Info to get your scores and all that. He broke that website also. Why? Because the massive load on the site took their site down. Now again you would say, why massive was there? Generally, Cricinfo anticipates around 5 million users over the day. Average the visitor is around 5 million on that time. That day, they had 45 million page views. Now you can imagine from 5 million to 45 million, how would it have worked? It's a tough, right? It would crash your site. How can you go to the market and get a new software just in 10 minutes? That may not work. Correct? So, what was so wrong about that? And can we help here? Or can we understand, can Amazon have fitted here? So let's try to understand that. Let's try to understand the how the Crick Info website and how Amazon might have come in a play here. So let's start that Crick Info started long back. So they started around in 2003. This is around this 2007, 10 or 8, and this is around 2012. Just rough a number we put here. Now coming to in 2003, they might have anticipated certain load. They said, let's make an application or which can support 50,000 users. In 2008, they started getting more load, so they might have procured. So considering this case, the blue line says we are thinking that Cricinfo is hosted on a traditional hardware, their own data center, where they are procuring their own infrastructure and doing that. I don't know what they are doing. I'm just using this case as a reference case study only. So in 2008, it may happen that they might have now gone more and they might have procured infrastructure for the 5 million. Now let's see what was happening really. So the real case was this actual demand was the rate part, right? So generally they were having almost 10k or 20k or max they were going the 30-40k people, because this was a in 2000p there was not so easy internet, the costly internet, the computers were not available easily, so not everybody had the Cricinfo access and they could do something, so people were not going. 30,000 was a good number. So most of the time their infrastructure was idle, because only if there is some special matches, the Indian matches, or there is something World Cups where there is more focus, it would have higher number. Else it would be much lower, and most of the time it would be underutilized resources. it started growing more. The 2008 something become more popular, more hard commoditizing of the hardware. People started getting that, and then it started more. So the load started getting more and more. So you would say in the some of the World Cups or before the 2003 7, there was something here. Load started from 50,000 to 1 million something they started. Even in the 2007 World Cup, it might have gone once in a while about 6 7 millions when there was a final match or something like that. Otherwise, it was normally within their limit. On that fatal day, the 2010, it might have happened, they crossed the limit. And no way they could have anticipated 45 millions. And even if they had anticipated 45 million, what could have they done? They know that 60 to 80% time my infrastructure is completely unutilized. I'm not able to make it. Why would I go and invest and procure some infrastructure which is going to be idle all the time? Rather, I would like to be down one day instead of investing some 20, 30 millions in my infrastructure. Because the most of the time, 364 days, it's idle. It's not going to cross that, right? You have to understand the business case also. What if you have a software available or you have a cloud power available which was able to scale up and scale down as and when required? Today, forget this, the actual demand. See on the yellow line. If the same infrastructure was hosted on Amazon, Amazon started by the way by 2007, so I just go with that. So if in that case they needed 30,000, let's provision a capacity of the 50,000. Now here they need 10,000, let's provision the capacity of the 20,000. So in any time you would always have a some buffer available. So even if there is a sudden spike, you would be able to meet. You need the 1 million, let's make it for the 1.5 million. You have some buffer available. It would be 50% more than what you needed. Here you need only 70k. We would provision you 90k or 1 million, something like that. So, but advantage is whenever you need, it is able to scale up. Whenever you don't need it, it is scaled down. So you pay using pay as you go model. You would be paying only when there is a higher load. When there is a lower load, you don't pay for that. Take the case of that 5 million to 45 million. Amazon would be able to scale up more. Again, going to 5 million to 45 million needs your better planning, architecture, design, everything would be there. But Amazon has the power to provide you a capacity. You need 5,000 machine, you need 10,000 machines. I am ready to give you. You take it. Are you ready to pay for those 10,000 hours? Because if you're going to use for 1 hours, 2 hours, 8 hours, you pay me for only for those hours. Isn't that a great thing? Use it only when you need it, else dispatch it and pay only for the time you are doing it. Imagine a case you have the electricity. Now, even if you are out of town, you are not using electricity at all, your all switches are off, it would say, sir, I am going to charge you. I have to offer you every day, I would charge you $50. Or you have to procure this much electricity because you have to. You would say, why? Why would I do that? Why should I pay you? I'm not using it. Same thing is possible here in cloud. Pay as you go model. You can do that only when you are using. So you are not ready to pay for the electricity. Why are you going to pay for your infrastructure also? Cloud says if you don't want to pay upfront to your electricity, you pay only for your usage basis. Or you take a taxi and taxi wala says, sir, I am this man, I will charge you 2,000 rupees whether you sit me or not, you use me or not. If even if my car is down, you have to pay me 2,000 rupees. You would say, why? I have now Ola, taxi for sure, everything. I run for 30 kilometers, I would pay only for 30 kilometers. That's the power of the cloud, right? Elastic and pay as you go model would help you to save lots of money, and as well at the same time, since they were virtually unlimited resource, you can scale up and scale down more. How would that work here in the Amazon? Amazon offers scaling services with three services we can call up: Amazon CloudWatch, Elastic Load Balancing, and Auto Scaling. Elastic load balancing is a service which would be a load balancer service. Now, what does a load balancer do? If you don't know, if you have a huge number of traffic coming, it would distribute to the multiple servers lying underneath that. So you have a 3 servers, you have a 300 users coming, each server would be routed 100 users. So evenly distributing your traffic. What is autoscaling doing? Autoscaling is a service which would be able to scale up and scale down like what we needed in the here automatically. So today you can configure that if my CPU is more than 50%, add 100 more servers. Or if my CPU is less than 10%, remove 20 machines. Amazon would be able to do that with autoscaling automatically, no manual intervention. And how would CloudWatch help you? CloudWatch is a monitoring service which would not only monitor load balancing and auto scaling, but at the same time, it finds that if there is a something breaching the threshold, like if it crosses 50% or if crosses less than 10%, CloudWatch monitors that and notifies auto scaling to take action, saying that remove 20 machines or add 100 machines or do something. That CloudWatch will do. So these three services are the basic for the scalability part. And when these three services work together, they would give you fantastic output. They would help you. Let's understand the case of the Cricinfo. At the Cricinfo level, hold on, where is my pen? Just a moment, my pen is gone. Oops, yeah, good, it's back. Now, take the case of the Cricinfo. So for the 5 million users, they say we have procured almost 5,000 machines, right? So each machine can take almost 1,000 users. If I'm doing the maths right, correct me if I'm doing wrong. But just take the number as of now. Each machine can take the load of the 1,000. Now you have set up an elastic load balancer which is distributing among those 5,000 machines. It might happen you might have a multiple elastic load balancer also to support this. Now, or let's go with the, you have a 500 machines with the 10,000 users. It's easy to explain on that way. You can have the both the case possible, so don't worry. Now you have 500 machines which each would be able to take the 10,000 users. Elastic load balancing is distributing the traffic. Now you also set up the CloudWatch to say that keep monitoring, and whenever my CPU is growing more than 50%, notify auto scaling to take action. So now the 5 million, the Sachin started playing well. He crossed the 50, and the from 5 million it started more on a 6 million. So instead of 10,000, there was more load coming here, right? Almost 12,000 something over there. So your CPU usage utilization was going to increase more than 50%. CloudWatch notified autoscaling saying, boss, there is a threshold. You need to do something. And autoscaling immediately took an action, added 100 more servers in the line. So now we have a 600 servers. Again, those 100 servers are already registered with the load balancer. So it would be now diverting traffic to 600 machines instead of 500. And how much time this process took? Just 10 to 15 minutes. It monitored, it captured, it scaled up, everything is there. And did it need any manual intervention? Not at all. Even you might not know it is doing that. Now 6 million to it reached to the 20 million somehow. Every time for certain usage more than 50%, it would keep adding more and more resources. So 600 to 1000 to 10,000 something, it would 1,000 machines, it would keep adding over there. It would be able to add more and more automatically as per your configurations. Now take the reverse case. When the load is decreasing, load is going below 50%, what would happen? Since it's less than 20%, you would be now notifying auto scaling, sir, the match is over, looks match is over. There is a less load now. Okay, so what would happen in that case? It would remove some more. So remove 50 machines or 100 machines, whatever you want to remove. Gradually start removing those machines also. And eventually in a day or some time, it would come back to your original 500 machine with the original 5 million load. It would work perfectly for you. Now you would think, why this is So helpful. Imagine, did it require any manual intervention? No. Did it scale up, scale down automatically? Yes. Did you pay for the infrastructure completely? No, I did pay only for the amount I used it. Was it able to meet your scalability part? Yes, it was. What do you need more? Your customers are happy, your finance is happy, your developers are happy because they did not need to do that. Aren't you happy also? Three service better together, right? I have a few questions, but I'll just finish it a little bit quickly. Now we were almost at the end, and then because some people already said they want to leave for the office. So just give me 5 minutes. And I'm just throwing an architecture for this. How would this look like in Amazon? Amazon would have a various services to offer for this. They would have a Route 53 service, which would able to do your domain name mapping with your, like you have a domain like edureka.co or hacloud.co, with your the whatever the IP address offered by Amazon, it would do that. This is your load balancer, which would distribute the load. It would have a Amazon storage service, which would store all your static content. It would have a content distribution network for the caching of the static images. It is having auto scaling group to scale up and scale down. EC2 machine is a virtual machine where your application would be hosted. CloudWatch alarm would be monitoring your services. SES is an email service which you can send to your users about anything. This is a caching service like Memcache based caching. This is the managed database MySQL or Postgre or Oracle or MS SQL available here. VPC is a your security, your own private subnet kind of a case, you can make that. And Ravi asked me this question, I'm just answering. This is the Amazon's offering, and not Amazon. This is the no SQL offering from Amazon. No SQL means not only SQL. Amazon offers DynamoDB. If you have heard the word called MongoDB, Cassandra, those are the popular example of the NoSQL. Amazon itself is having its own NoSQL called DynamoDB. So these are the cases, and this is how you can use to make the scalable architecture like before. Same architecture referred by Amazon like this. They say you use content distribution network, you use the resource and content, use the auto scaling group, and each service would help you in a way that your all user request. So whenever somebody requested, we start with that. Somebody requested crickinfo.com. So Amazon Route 53 would interpret crickinfo.com maps to certain IP address or DNS service which is running on Amazon Web Service. After that, that would be a static streaming and dynamic content delivered by the Amazon CloudFront. So if you are getting the image of the Sachin Tendulkar, you are getting something photos or videos, it would be serving you. This is like your Akamai, which would be caching your content to deliver you faster way. All those static content might be stored in the simple storage service. Your load balancer, which receives requests from the number one Route 53, would divert to your EC2 instances, which is spread across the different availability zone. So that would ensure your application would be highly available and would not, even if one of the server goes down, it would not crash your applications. They would be stored in the EC2 instance, and you can keep making an AMI. AMI is nothing but a ghost image kind of a concept, Amazon machine image, which you can always use to launch more and more machines in the futures. They are always part of this auto scaling group, so they can scale up and scale down based on that. And we are using the Amazon's own relational database service, which would be able to scale up and scale down for that. So that's how your reference architecture work in Amazon to meet your scalability need, meet your high availability need, meet your pay as you go, cost effective, as well as security aspect, everything it would be able to move that. And if you want to learn all this, you want to be part of this, I welcome you everyone. We have a course starting soon where we would be having an introduction to cloud computing, Amazon EC2 and Amazon EBS concept. We would be talking various Amazon services, and we would be also doing lots of architecture and design. How would you do with the Amazon architecture design with the Amazon? How would you be? And then we would be giving you some of the projects. I would be helping you. Our curriculum is designed to meet the Amazon solution architect certificate. So I would be able to help you. How do you prepare? Yeah, don't expect that I would be giving you the dumps. I would be giving you everything. No, that even Amazon does not give you. I would ensure you have the right foundation, you have the right practice, right tools available to get prepared for your certification, and you can clear that. So, my dear friends, this is Tarun for you. This is how we work Edureka, and we would be able to help you on that. And it's time for me to open the forum for all the questions. So we would be able to talk more. Now, let me go a little bit above, and if I can find the questions and I can answer that. If I missed any question, you always can ping me back also. So one question from Ravi was, in virtual machine, we create some data. What about data security? See, the Amazon and all cloud provides a various kind of a security mechanism. Even that access to, if you want to restrict the access of that database, you want to restrict the access of to public, or your only, you want to encrypt the data, everything is possible over there. They do provide. And when you remove that machine, that would be wiped out. Even they recommend if you want to wipe out on your own, you can do that. It's a possible. Chinmay has a question that do Amazon charges if the server is shutdown mode? See, shutdown mode is like there is Amazon as a two concept: start, running, terminate, and stop. It's a running, it would cost you. If it's a stop, it would not cost you for the running cost. Yeah, there might be some minor storage cost, it might be costing a little bit. If it's a terminated, Amazon would not charge you at all. And when I explained, if you join the course and when I explain Amazon services more, I would be able to explain more and more clear about that. So Ravi, I think I answered you the NoSQL database, which you would now know. So Ravi says, can we set the denial of request in Amazon? Definitely, Amazon provides the firewall rules. You can set that. Virtual firewall, Amazon provides that. Okay, so Komal has a question, when autoscaling done, which build it will consider? So what would happen? You have to make your own AMI where all your software and would be installed as part of that. And it's a, I'll tell you, one step process, just one right click and make an AMI. You can use that AMI with the auto scaling. So whenever in the auto scaling in the future launches a new instance, it would launch from that AMI. So it would have all your software and everything installed as part of that, and it would work for you. Right. So I think this answers Komal your question about the maintaining the latest build. This is how it would be. Madhu says, so does this mean except Amazon, no other cloud is doing such thing? No, I never said that. But yeah, Amazon is leading by its competitors by margins because of its innovative offering, so many services it is offering, so many things it is having, easy to use interface, and that's why it's leading, by the way. Okay, did I miss any question again? Okay, Ravi says, if demand cross threshold, it can clone images after done with demand. It will automatically shut it down for the next time. Do we get the same clone image or new one? I think I just answered Ravi that you would need the AMIs to manage. So AMI would be able to launch a new instance every time. Mohammed has a good question. Do you think cloud is good for small companies where you have only few users to start with? Cloud is great for the startups. Great for the startups because you don't have to invest a lot in the infrastructure. Now, I'm sure you would have a lot of startup concept and you have the thoughts, right? How would you work that? How would you be able to manage that when your user grows, you don't have to go run to the market and procure new things? With the cloud, you can do within a few minutes. That's why it's a great thing. At the same time, you would not have a baseline cost here because it's a pay as you go model. So whatever you are using, you would be paying only for that. You're not going to pay for anything. So it would be also very cheaper, right? So Hari Krishna has a question, when autoscaling happens, the new instance, how they sync with the content. I think I answered that you use the AMI. Every time you change anything content over there. Now content is a two part. One is the application configuration, another is a database. Database you don't scale, you just change the application part. And application part would be coming from the AMI aspect. Yeah, so Mohammed says it is running, but my users are not using as of now. What would I do? That's why the Amazon would come in a picture. It offers you the cheapest service called the micro instance, which is just a 600 MB RAM, where it might be a free of the cost also. You don't have to worry. And when you grow, you start using more. You might not pay also for that. So Ravi and others ask, how can I join the next class? We have this registration part. You can always register to our Edureka curriculum. Go to our course and you can always register for that. Okay. Any other question which I did not? Just want to know your feedback. How did you like? Are you clear with the cloud? You enjoyed? Thanks, Mohammed. Thanks, Shashidhar. Thanks, Ravi, for the feedbacks. Thanks, Madhvi. So hope we would meet in the class soon. And with this, I would like to end the session. Thanks all for joining. Have a nice time and hopefully we would meet again. Bye-bye.